All right. Um, the first section of chapter 5, we talked about exponents, and we talked about doing a lot of different things, all those different properties of exponents that we talked about on Thursday and then a little bit more on Friday, which kind of leads into our topic for today, which is polynomials. We've seen polynomials before. Today is really just going to be what is a polynomial, what are the different types of polynomials, what are some different things about polynomials that we're going to do, and then we will do some operations with polynomials. Today's going to be addition and subtraction, and then we'll talk about some more later on in the chapter. All right, so first up is what we call a monomial. A monomial is, the prefix mono means one, okay? And so a monomial is one term. So it's an expression that is a constant or product of a constant and variables. Okay, so examples of a monomial. If I say a constant, what are we talking about when we talk about a constant? If something is constant, what's that mean? Stays the same, right? So what's something in math that always stays the same? Doesn't change. Like 8, right? 8 is always 8, like any number. Any number is a constant, yeah? And here's why it doesn't change, because it doesn't have a variable, right? Variables make things change. Variable means to change, and 8 will never change. 8 is always 8. So any number all by itself is considered to be a constant. I could do like 6x. That would be a monomial. I could do 7x, y squared, z. I can put as many variables as I want to, as long as it's only multiplication. We don't want any addition or subtraction or anything like that. But if I'm just multiplying all these things together, then that is a monomial. It could even be a division like that, because this would be the same thing as 1/3 x squared. Those two are the same thing. This would probably be a little bit easier to write it like this. That's why we probably would prefer this. But it's still multiplication because we're multiplying 1/3 by x squared. So it's still a product because we're still multiplying. Just written a little bit differently is all. So those are all examples of monomials. The biggest thing there is you can't have any plus or minus signs. No addition, no subtraction if we have a monomial. Okay, another vocab word. We've seen this one throughout the years. Coefficient is the number in front of a monomial. So in this case, 6 is my coefficient. 7 is my coefficient. 1/3 is my coefficient. Those are all the coefficients of those terms. This one doesn't have a coefficient because there's no variable. We always say it's the number directly in front, and if we don't have a variable, we don't have anything in front. If we had x, y, z squared, and there was no number in front, what number is assumed to be in front? 1, okay? So there's always an assumed 1 right here. if there's no other number there. So if I have a variable, there's always a coefficient. If we don't write anything there, then we always assume that coefficient to be 1. Okay, degree. Degree is the sum of exponents of all variables in a monomial. Okay, so I'm going to rewrite all of those terms that I wrote up above. 8, 6x, 7, x, y squared, x, y squared z, and 1/3 x squared. Okay, and we're going to talk about the degree of each one of those. Okay, so it's the sum of the exponents of all the variables in the monomial. Okay, let's start with 6x first of all. 6x, and I'm just going to put D for degree. If there is no exponent, kind of like if there's no number in front, we know that's assumed to be a 1, like we said here. If there is no exponent, that's always assumed to be a 1. So this would be like 6x to the first. So my degree is 1. Because it's the only variable, there's no addition that needs to take place. So my degree is just 1. For this one here, this is an assumed 1, this is a 2, this is a 1. So x and z both have an assumed 1, so my total degree would be 4. For the last one, the only variable that we have is x. The exponent is 2, so my degree is 2. The very first one does not have a variable, so if there is no variable, that means there is no degree. So my degree is 0. And so we would always call it, or name it, based off its degree. And that's going to be a common thing that we're going to see when we talk about degree. And after today, most of the time when we look at a polynomial, it's not going to have multiple variables within it. It's just going to have an x most of the time, maybe different variables other than x, but x is going to be the most common variable that we're going to see throughout this chapter. Okay, a lot of vocab today. The next one is what today's lesson is all about, a polynomial. A polynomial is a sum of monomials. And I'm not saying difference because it could be subtraction, but if I say plus a negative, then we might see a minus sign. So if you want to add the word difference, you could do that. Sum or difference of monomials. And all that means is we're going to take two different things and add them together. Two different monomials. 3x is a monomial, 7 is a monomial, and when I put those two together, we would call this a binomial because there's two terms. If I did 6x squared minus 4x plus 8. This one is what we call a trinomial. These three terms cannot be combined together because they're all different. You got x squared, you got x, and then you got an 8. 3 separate terms, all separated by either a plus sign or a minus sign. Each addition or subtraction sign separates into multiple terms. So because we have 3 terms, we have a trinomial. Tri means 3. This one's a little bit different. This is still a trinomial, but it's like a trinomial with multiple variables. It's got x's and y's in it. And typically, from here on out, after today, we're not going to see a lot of polynomials that have multiple variables in them. They'll just have an x. It'll be more like what these first two are. That's going to be the most common way that we're going to see polynomials written out. So those are all different examples, and you could keep adding more and more terms to it if you wanted to. You could end up with 4 terms, 5 terms, 6 terms, and more. But most of the time, we're going to deal with binomials and trinomials the most throughout this chapter. Okay, if I wanted to find the degree of a polynomial. So we talked about how to find the degree of a monomial if it was just one term, but what happens if there's 3 or 4 terms in a polynomial? It is going to be the greatest degree of any term that's in that polynomial. So I'm going to give you a couple of examples here. Okay, this is a trinomial. We got 3 separate terms in this trinomial. What's the degree of the first term? 6. What about this one? 2. And this one is 3. So my degree of the polynomial is the one that's the highest. And so here we would say that this one has a degree of 6. 6 is the biggest. We're not going to add all of the exponents up separately, okay? Because each one of these is its own term. When I did monomials up above, it was all one big term. So we added the exponents, okay? But we're not going to add 6, 2, and 3 together here to get a big degree. We're going to take the one that's the biggest out of all of them. And so if I had 4 terms, you're going to look at all 4 terms and figure out which one's the highest. Okay, this one's a little bit different. Once again, we're going to do each one individually, right? So each term, first term has a degree of 5. Second term has a degree of, this is a 3. It doesn't look very good, right? This is a 3 right here. So that one would have a degree of 7. This one is 1 and 3, which is 4. This is 2, and this is 0. So the one that's the highest is 7. So we would say that this one has a degree of 7 because we're going to add those 2 together and make 7. So which term has the highest degree? That's the degree of the polynomial. Okay. Questions on degree? So it just depends on if there's one term or multiple terms when I try to find the degree of it. Okay. The last thing with all of these polynomials, and then we'll do some examples of some different things, is what we call standard form. Standard form is the way that we will typically write a polynomial. We always go in descending order of exponents. You guys remember what descending means? Going down, right? Descending, we're going down. Ascending is going up, descending is going down. So we're going to go from the highest down to the lowest exponent or degree. Okay, so for instance, if I gave you one like this, 4g squared plus 5g minus 4g cubed plus 7 minus 8g to the fourth. If I were to rewrite this in standard form, standard form means we're going to start with the highest exponent or degree, and we're going to go to the lowest exponent or degree. So what's the highest exponent we have here? 4. Okay? So this whole term is going to come first. Not just the g to the fourth, but whatever is in front, whatever coefficient it has, is going to stick with it. So we're going to rewrite it as negative 8g to the fourth. That whole thing is all together. And then we're going to go 4, 3, 2, 1, 0. So we're going to go minus 4g cubed plus 4g squared plus 5g plus 7. So we're going 4, 3, 2, 1, 0, all the way from the highest down to the lowest. And what that does is helps me to put it in the correct order. Now I can say this is a degree of 4 because 4 is the highest exponent, so the highest exponent should always be the first exponent. And then we can do some things with it. But we're going to want to put it in this form a lot of times because when we start doing things like addition, subtraction, multiplication, eventually division, then we want to put it in standard form before we do any of those operations. Throughout the rest of the chapter, we're going to be doing operations of polynomials. Today is going to be addition and subtraction. And then tomorrow we're going to do some multiplication. And then on Wednesday, we'll do some division. Okay, so let's start with addition. And these could be written lots of different ways. But typically, this is the way that most of these are going to be written. And a lot of times, they're already going to be in standard form. So they're already set up in the way that we want them. But if they're not, we want to get in there. Just because it's easier then to put them together and combine them. All right, so in some cases, some people like to stack these on top of one another. Okay, if that's something you want to do, then by all means you could do that. Do you have to? Not necessarily. It just kind of depends on your preference there. So if you wanted to, you could take this whole thing and you could move it underneath and just kind of line everything up. Just makes the addition a little bit easier. Kind of like you would have added numbers way back when. Everything's aligned, and then I can just add straight down. But you want to make sure that x squareds are on top of x squareds, x's are with x's, and numbers are with numbers. Okay, that's the one thing you just want to make sure of. Do you have to do that? Not necessarily. Most of you could probably add these together without doing that, and I'm totally fine with that. So now when we add this together, what do you think our exponent's going to be here? 3x squared plus 4x squared would make 7x squared. Yeah. Because we're combining like terms, right? And when we combine like terms, we don't do anything to the exponents. We got 3x squareds here. We got 4x squareds here. When we put them together, we got 7 of them. We got 7x squareds. Okay? On our properties last week, in order to add exponents, we got to multiply. If I took like x squared times x to the third, we got x to the fifth. So that's multiplication where we add the exponents. This is not multiplication. This is addition. So that's not the same as what we did last week. Negative 6 plus 1 would be negative 5x. And 1 plus negative 7 would be negative 6. And that's our answer. Okay. Addition's pretty straightforward. We're going to combine everything that can be combined and put them together. If I did another one where, let's say, we did something like this. This is where I think the stacking kind of helps, because this one has 3 terms. This one only has 2 terms. So we got to make sure that we're combining things together that are alike. This one has an x squared. This does not have an x squared. So we aren't going to be able to combine those together. So if we were to stack these, 3x goes underneath the 4x, minus 9 goes underneath the minus 8. Okay. So that shows me right there that I don't have any other x squareds to combine with the 6x squared. And so then, just really watch your signs. This is negative 8 plus negative 9, which would be negative 17. And then that would be our answer. Okay, so you won't necessarily have, if this one's 3 terms, this one over here is not necessarily going to be 3 terms. But you got to pay attention to what terms do I have, because this easily here could have been x squared right here, and maybe we're missing an x in this one, or maybe we're missing a constant. So each one's going to be just a little bit different. We can only combine things together that are alike. Okay, so that's where you got to kind of watch out on that. Okay, another operation that we're going to do today is subtraction. Once again, these could be written lots of different ways. But the way that we're going to see it written most of the time is something like this. Okay, and parentheses are really a big deal here. With addition, it really didn't matter, because we're just combining things together that are alike. But because we have a minus sign in front of this parenthesis, what do we have to do with this minus sign? You got to distribute it, right? We got to subtract all 3 of these terms. And some people would say, well, I can just subtract. But what's going to happen is you might remember to subtract x squared, but you're probably going to forget in some cases to subtract 2x and subtract 1. Or what happens if this was a negative 1 right here? Now I have minus a negative 1, right? So what I would probably do, what I think helps the most here, is to keep the first one exactly the same. We're going to change this to a plus sign, and we're going to distribute the negative throughout. We're just going to make this an addition problem. And all we did was change the signs on all 3 terms. Okay, once again, do you have to do that where you have to rewrite it and put negative on all of those? No, but that's one way I think to be more successful on these that I would recommend. It takes a little bit of time to rewrite it, but I think we'll have better success if we do that. Okay, some of you are just going to be able to say, I know 9 minus 6 is 3, and so on. Once again, if you want to stack it at this point, you could, but we're just going to go ahead and add it together here. 9x squared plus negative 6x squared would be 3x squared. 7x plus negative 2x would be positive 5x. 5 plus negative 1 would be 4. And that's our answer. Okay, so subtraction is not much different. The only difference you got to be careful of here is you got to distribute that minus sign throughout everything, and the second parenthesis. Okay. Questions on addition, subtraction? Pretty straightforward, yeah. Don't change your exponents today, okay? Nothing here, your exponents will not change today because we're not going to see any multiplication. Tomorrow we'll see multiplication, so that's going to change our exponents today. That's not going to be the case. Okay, here what we're going to do is we're going to talk about the different types of polynomials. Most of these, if not all of them, you guys have seen before. And you've done a lot with these. The other thing that we're going to do here is we're going to talk about what the minimum, maximum, the domain and range is going to be for these. So let's start with the first one. A lot of these are going to be written in function notation where we're going to have the f of x. We talked about function notation earlier in the semester. Here it is again. And we're going to have a lot of these written as functions. And so you're going to see f of x instead of y. But it means the same thing. I could write y equals 3. If I wanted to put this into my calculator, I could put it in as y equals 3. If I graph this, what does the graph y equals 3 look like? It's horizontal line. Good. We're going to go up 3 on the y-axis, and it's going to be a horizontal line. That would be a constant function. Constant functions will stay flat, constant all the way throughout. It doesn't go up, it doesn't go down, it just stays constant. Okay, and we call that a constant because it has a degree of 0. So now we're going to work our way up. Okay, we started with the degree of 0. If we have a degree of 1, f of x equals 2x plus 3 would be an example. What do we call that equation? What's the name for a degree of 1? Starts with an L. What kind of graph would this make? Seen it before? Linear, right? It makes a line. Okay? Slope-intercept form, right? It's just a linear equation. And so y equals 2x plus 3 is a linear equation. Degree of 1 is a linear equation. If I were to graph this one, we're going to go up 3. Then we're going to go up 2 over 1. Okay, we haven't talked about this a whole lot this year, but I know back in Algebra 2, you talked about domain and range of these types of functions. Domain is always going to represent your x values. How far left to right this graph is going to go, okay? How far left and how far right would this go when I think about x values? Forever, right? And so we would have said all real numbers back in Algebra 2, and that's not wrong, okay? But the way that we're going to write it going forward is negative infinity to positive infinity. That's the way that we express all real numbers when we do that interval notation that we've talked about at times this semester. It's not wrong to say all reals. I'm not going to count it wrong if you say all reals, but you're going to see this, especially as you get into college algebra. If you take college algebra, then we use interval notation all the time. So it's something we got to start kind of being prepared for and starting to see. Range is the same thing. Range is your y values. How far up and down is this going to go? It goes down forever, it goes up forever, and so my range would be negative infinity to infinity. It's going to go both directions forever. Okay, third one. A degree of 2. A degree of 2 would look like this. F of x equals x squared minus 2x plus 3. Anybody remember what we call this one? A degree of 2. Constant, linear, and then the next one? Quadratic. Good. Another one that we've had some experience with in the past. Going back to Algebra 2, we saw quadratic a lot, solved quadratic equations. We're going to see those a lot more going forward this semester. Haven't seen them a whole lot up to this point. If I graph this one, and we could put this into our calculator.
Is it plus 3 or minus 3?
Oh. Yeah, I meant to put a minus 3 on my equation, but yes. Thank you for saying that. So this should be, now it won't let me change it since I got out of it. Should be a minus 3. So 1, -4 is my minimum value. Okay, now if we talk about domain and range here. Domain of a quadratic function is always going to be what? All real numbers again. Okay, so it's still going to be -infinity to infinity. It's going to stretch left to right forever. It's going to keep going, both directions, left to right. But my range goes up and down, right? My range, as I move up and down, this is the lowest point it will ever reach. It will never get any lower than this. And so -4 is my y value right here. So this graph will never get any lower than -4. So the way we would write our range here is we would say -4 up to infinity. If my graph would open down, then I would say -infinity all the way up to that high point. And that would be the only difference. So does it have a minimum or does it have a maximum? Is that the highest it's ever going to reach, or is that the lowest it's ever going to reach? So those are just a little different. Okay, the last type of graph has a degree of 3. So an example of a degree of 3. Highest exponent is 3. What do we call this one? If I take something and raise it to the third power, what do we say that we're doing? Cubing it, right? So this is a cubic polynomial. Anybody remember what a cubic graph looks like?
Excuse me for the announcement. For anyone that has signed up to use the flu shot, they are here right now, and they are here till 11.
The one that I gave you here kind of looks like this. In some cases, a cubic might look more like this, where it has more humps to it. Hey, this one did. The first one I didn't really have a hump to it, and it may or may not. Or it could start up here and look like this. Those are all examples of what a cubic might look like. Linear is always going to be a line. Quadratic is always going to be the parabola, the U-shaped graph. And cubic's always going to have this kind of curve look to it. What do you think the domain would be for any of these three graphs? How far? All real numbers. What about range? Up and down. All real numbers. Okay, so this one's pretty easy. Domain and range are -infinity to infinity for both. So the only one you really got to be careful of here is quadratics. Quadratics are the ones that are going to have a little bit different range. All right, last thing we're going to talk about today is function operations. And this kind of goes back to what we did just a second ago. If I gave you two functions, we could do f plus g of x, or we could do f minus g of x. So we have two linear functions, and this tells me all I'm going to do is add those two functions together. So if we add these two functions together, 2x plus 7x would be 9x, 1 plus 3 would be 4. If I'm going to subtract them, probably not a bad idea to write this one out. A little bit harder than addition. And remember, we're going to distribute that minus sign throughout. So this is 2x minus 7x, which would be -5x, and 1 minus 3 would be -2. So you just got to be really careful about operations in science. Okay, so that is, and then it for today. Kind of a long lesson again today. Going by fives, and we're skipping number 75. 10 to 85 by fives.